let's write down the definition of a dot product. So we have added vectors, we've subtracted vectors, we've multiplied numbers through vectors. One thing that we haven't done is multiply vectors because we don't do that. Instead, we have something called a dot product, and it looks like multiplication. It's not really multiplication. It's a calculation we can do with vectors that ultimately shows up in a lot of formulas. So right now, on its own, it doesn't really mean a whole lot, but we can apply it to some different things that we calculate with vectors. So the dot product, V dot W is how I would read that, of two vectors, and these are the vectors. This is just kind of arbitrary, so vector V is V1 and V2, whatever those numbers are, and vector W is W1 and W2, whatever those numbers are. Here's the actual formula. This is the calculation you do. It says you're going to multiply V1 times W1, which are the numbers that are first, the horizontal components. You're going to multiply V2 times W2, which are the vertical components, and then you're going to add those together. And then your answer for a dot product is just going to be a single number, and that's it. Okay. So let's find V dot W for the following vectors. First problem, vector V is 1, 2. Vector W is negative 2, 5. I'm calculating V dot W. Okay. So I'm going to multiply the first components together, multiply the second components together, add those numbers up. In this set of vectors, it would be 1 times negative 2 plus 2 times 5. The dot product is 8. That's it.
I can do this now.
Good.
I feel like it's harder.
I mean, there's already letters in the next one. So.
And that's it. That's the whole lesson on dot products now.
Yeah. That would have been a
It's the same thing. It's 4 times 8.
So it's the same thing. Remember, the I and J are just a label, really. Tells us what's the horizontal and what's the vertical. So even if it's in this form, same calculation, 4 times negative 3 plus negative 3 times negative 4. So I would get a dot product of 0.
Why is that important?
Well, we're going to use it in the formula in a minute. So we need to be able to do this calculation. Okay? You always add. Yes. Well, it depends what's in the formula.
Yeah. My bad.
Or subtracted.
Multiplied and divided.
Okay, good. All right, so an example where we use this dot product formula is to calculate the angle between two vectors. This formula, it's actually the exact same formula written 3 different ways. You just really need to write down the first one. So theta is not to be confused with the direction angle here. This theta is the angle between two vectors. Okay. To calculate the angle between two vectors, you need to be able to find the dot product, which is what we just practiced. You need to be able to find the magnitude of both of your vectors, which we did that in the last section, and then you just plug those numbers into the formula and solve for theta. Okay. Well, because each of those vectors has 2 bars on either side of it.
Yeah, that is a lot.
So there's 4 between the V and the W there, I
The
know.
lines there.
It's gonna confuse me. I'm gonna think it's a 1 because it's like 11.
That doesn't even look like a 1.
No, but like right next to a number.
I think that looks like.
All right, everybody have the formula written down?
Yeah.
Okay.
Right next to the number. That was
Sorry.
So you don't have to.
They're all the same thing.
Well, the last one looks
It looks
really different.
It's just if I solve for
It
theta.
looks like I
That's it.
don't know how to write Roman numerals.
Yeah, like
Yeah,
can't
yeah, it
do all of
does.
that.
Okay, so we're going to skip over the proof of that formula. We'll just not worry about that right now. Okay, let's go to a problem. If V and W are 2 vectors, and those vectors have magnitudes 3 and 8, respectively, we're going to find V dot W. Okay, we know the angle between them is 60 degrees. So we are using this formula. Magnitude V times magnitude W times cosine theta. Okay. So this is, you can think of this as like an alternative way to find a dot product. If you don't have the actual vectors, but you have information about the vectors, you can use this. So the magnitudes of V and W are given to us, 3 and 8. And then the angle is given to us, cosine 60. And because it's 60, I actually don't need my calculator at all because it's a unit circle value, so I should be able to get an exact answer here. So 24 times, what's the cosine of 60? A half. So my answer is
12.
12 is the dot product.
Wow.
Aggressive. Wow.
That was not aggressive.
Oh,
It was-
is there some
Exciting.
force behind that?
That was it. It was exciting. Okay, so think of this right now as an alternative way to find our dot product. Any questions on that problem?
Oh, wait, I thought that was the angle. Oh, that's.
That is the angle
They gave
formula.
us that
So in this case, we weren't solving for the angle, okay? But in the next problem, we are going to solve for the angle. All right, so here we have two vectors. Vector v is 2, -3. You have the i's and the j's there if you want to write in that form. W is 3i and 5j. We're going to find the degree to the nearest tenth of a degree. I'm going to write the formula down one more time here. V dot W, magnitude V, magnitude W, cosine theta. Okay, so if I'm going to solve for theta, I need to be able to plug in the other three things. I need to know the dot product of V and W. I need to know the magnitude of V, and I need to know the magnitude of W. And if you have the vectors, you should be able to calculate that. Okay, so dot product, let's do that. So that's just multiply the first numbers, multiply the second numbers, add them together, right? So for V and W here, it would be 2 times 3 plus -3 times 5. So what's my dot product? -9. Okay. Then magnitudes, those are just our little Pythagorean theorems that we were practicing in the last section. So square root, you don't need the negatives because they're squared anyway. 2 squared and 3 squared are going to give me rad 13 for the magnitude of W, or V, excuse me. And then magnitude of W, I would do 3 squared and 5 squared, which will give me 25 and 9, rad 34. Okay, so just little pieces that we need to be able to plug in the formula. Are we okay?
Yeah.
Yeah? All right. So now plugging it in, the dot product part is -9. Magnitude of V is rad 13. Magnitude of W is rad 34. Cosine theta. All right, and we need to solve for theta. I'm not going to type anything in until the very end here. The first thing I'm going to do is I'm going to take those radicals and I'm going to divide them over to the other side. You can divide them both over at the same time. So -9 over rad 13 and rad 34 equals cosine theta. And then what would you do to solve for theta? Inverse cosine. Okay, so ran that formula that had the inverse cosine that you thought was so crazy. This is it. It's right there.
That's wild.
Okay, so they just like did that for us. All right, so that's what you're going to type in your calculator now. And you're just going to round to the nearest tenth.
Are the tests or quizzes, are we gonna have a graphing calculator or?
You'll at least have a red calculator. I can't remember if the quiz next week is graphing calculator or not. Escape room's Monday, quiz on Tuesday. I'll get back to you about calculator use on Tuesday. 115 point what? 3 degrees. Okay, any questions on that? No? Okay, we're just gonna do one more thing. I'm gonna kind of jump around here for a minute. No, not a new formula. It's a definition using dot product formula still. Okay, so the last thing we're gonna talk about today are parallel and perpendicular vectors. We'll talk about why there's a different word instead of perpendicular up there in a second. All right, so parallel vectors are vectors that are either 0 or 180 degrees apart from one another. That's the angle between them. It's either 0 or 180. So it could look like one of two things. 180 means they're going in opposite directions. But if they're going in opposite directions, their slopes are the same. You can see that those are parallel to each other. That's 180. Or it could be 0 degrees between them. So that would kind of be on top of each other, something like that, which again, you can see that those are parallel. So same formula, calculate the angle between the vectors, but if you get 0 or 180, we can just label it as parallel, okay? Then, if you calculate the angle between vectors and they're either 90 or 270, we label it orthogonal, okay? Now, orthogonal means perpendicular except in one case. The only case where it doesn't mean perpendicular is with the 0 vector. Do you guys remember in that video you watched, I talked about the 0 vector? The 0 vector is 0, 0. It has no direction. So technically, it can't be perpendicular to anything. but you'll get a 90 or 270 when you solve with that one. So that's why we can't call it perpendicular, because of that one little special case. So they say orthogonal instead. But we're still looking for the vectors to be either 90 or 270 apart. Those will have a right angle between them if you draw them. In order to get an angle that's 90 or 270, it means the cosine is 0. And I can take it one step further. If I work backwards in my formula, it actually means the dot product will be 0. As soon as the dot product equals 0, because it's 0, the cosine will also equal 0, and therefore give me a 90 or 270 angle when I solve for it. So orthogonal, we actually have a shortcut. We don't have to go all the way to solve for the angle. We can just figure out, hey, the dot product is 0, so those are orthogonal vectors, period. Okay? Good?
Yeah.
Okay. All right, so parallel is either 0 or 180. Orthogonal is like perpendicular, 90 or 270, or you can just remember the dot product equals 0. So the second problem we did today was an example of orthogonal vectors, because we got a dot product of 0. Okay? All right, I just got 2 more problems then that have to do with these. So you're going to see Math XL questions that are kind of multiple choice. It's going to give you 2 vectors, and it's going to say, are they parallel? Are they orthogonal? It should say orthogonal. That's what we're going to use, or neither. All right, so the first thing I'm going to do in both of these is I'm just going to calculate the dot product, because if the dot product equals 0, I'm done. Okay, let's do the dot product of this guy. So vector v is negative I minus 2j. Vector w is 2I plus j. Dot product, multiply the first numbers together, negative 1 times 2. Multiply the second numbers together, negative 2 times 1. I'm going to get negative 4. So are they orthogonal? No. Okay, so these 2 are either parallel or neither. I'm going to go over to b and do the same thing. Calculate the dot product. 4 times 2 plus 8 times negative 1, and we do get 0 for this one. So this set is orthogonal, and I'm done. I don't have to do anything else with that problem. Okay. All right, now for back to part A now, I need to figure out if it's parallel or not. So I'm just going to continue with that angle formula we used a little bit ago. In order to use the angle formula, I still need to find magnitude of V and magnitude of W. All right, so magnitude of V, so our little Pythagorean theorem, would be a 1 squared and a 2 squared, which is rad 5. W is going to be a 2 squared and a 1 squared, which is also rad 5. Okay, so now the formula, just refresh here, dot product equals magnitude, magnitude, cosine theta. All right, so negative 4 equals rad 5 times rad 5 cosine theta. You probably don't even need a calculator for this one. What's rad 5 times rad 5? 5. And then if I divide that over, I get negative 4/5. Am I going to get out an answer that's 0 or 180? Does cosine equal 4/5 or negative 4/5 at 0 and 180? No, it should be either a 1 or a negative 1 at this point if I'm going to get 0 or 180 out. So it's not parallel. It's not orthogonal. This is an example of neither. Okay? All right. Last question. That was one. That was a part A and a part B. Not so fast. Okay. So vector V is ki minus 2j. K is missing. We're going to find it. Vector W is 4i plus 6j. We're going to find K so that A, the vectors are orthogonal, and actually we're going to do parallel also because you're going to see one on Math XL. Okay, so in order to have orthogonal vectors, what needs to happen? All right, the dot product needs to equal 0. So what we're going to do is we're going to set up a dot product. We're going to start calculating the dot product of what we have, except we just don't know what K is, so I'm going to leave it as K. So my first components are 4 and K, which is just 4K if I multiply them together, plus multiply my second components, negative 2 times 6, and if they're orthogonal, it should equal 0. So I create my equation, equals 0. And then you just have this little linear equation to solve. So 4k equals 12, and Andrew is right, k is 3. Then you can always double check it. If you make k equal to 3, double check that you get a dot product equal to 0.
I really want to know what's going on.
Okay. Parallel. All right, so we're going to use knowledge about parallel lines that we know. What do you know about parallel lines?
They don't touch.
Same slope. That's the fact that we're going to use. And how do you calculate slope of something?
And so wait, rise over run.
Rise over run.
That's just the whole.
M is the
line.
slope. Yeah, the whole line. Okay. And if you have an X and a Y, which one's the rise and which one's the run?
Y is rise.
Y is the rise, your vertical, and X is the run, right? Your horizontal. Okay, so we're going to calculate for each of our vectors the rise over run, and then I want them to be parallel, so I set those equal to each other. So for vector V, my rise is -2, and my run is k. I don't know what that is. For vector W, my rise is 6, my run is 4. How do we solve for k? Just cross multiply. So -8 equals 6k, and then if I divide by 6, I'm going to get what? -4/3. When you do this problem in Math Excel uses the angle formula to do this calculation, and it gets very complicated. I would not utilize to help me solve this for that problem because it's going to make you very confused. Okay? It's much simpler. All right, tomorrow we will finish up 7-5, and Friday you have a work day.
What were our tests?
They're actually graded. I'm going to put them in as soon as you leave.
Can you tell me how bad?
You can call Stark State tonight,
Yeah, but
and you
haven't
can
even
get
put it in
your
yet.
account